Hello, my name is Mark Long with Carlson Software, and welcome to this video tutorial on using Carlson software for preparing HEC-RAS input files. To begin with, let's go over our project using this tutorial. This project contains contours, points that I use to create a surface model or a TIN file, and the center line of the stream channel. As you can see here, it's a thick blue line. The stream channel must be drawn downstream to upstream, and this is the most important requirement used in this process. To prepare the HEC-RAS input file, every channel is defined by a cross-section alignment or MXS file and the actual cross-sections or SCT files. These are used to define the channel geometry data to be imported into HEC-RAS. Also understand it's very important the stream network must have a unique stream ID and a reach ID, and together these items identify the channel. To create the cross sections, we must first define our cross-section alignment or the MXS file. To do this, I will go into the sections menu under the civil, go into sections, input, edit, section alignment. Here I will specify new, and we'll call this channel A. And now the command prompt reads, select the centerline file that represents the centerline. Select our 3D polyline, and we can station this alignment. I will start at 0. And this dialog box represents the station interval. We can specify what station interval we want, our left and right offsets, and I'm just going to keep this very simple and station it at an interval. Select OK. You can see that our section alignment has been, the alignment MX file has been created. We can save and exit. It shows a graphical representation of where the cross sections were cut. These will disappear. It's just a representation. And so now I would want to go back and draw my section alignment to actually draw my cross sections. Draw section alignment, select the alignment file. I will specify a layer, and I do want to draw the alignment polylines to be used for the HEC-RAS program. So now you can see that I've drawn my cross sections. Next, let's create the cross sections. So if we go to sections, create sections from a triangulation surface which I've created based on the points and contours in my file, and I can specify that I want to use the surface file called EG, and link our sections is fine. And now we're going to choose the alignment file, which is channel A, and now specify our new cross-section name, which is also channel A SCT. Yes. And so now the program has gone through and cut the cross sections along our alignment. And we can view these by coming down to input, edit, section file, and select the cross section file itself. And now we can open it up, and by clicking next, we can scroll down through each cross section that we cut, or go backwards with the previous button. But at least you can see what you have done. Hit cancel and close. Now we're ready to go ahead and go back to hydrology and create our HEC-RAS file. Click on the rain cloud, come to watershed menu, come down to HEC-RAS water surface modeling, and prepare HEC-RAS input file. This dialog shows the header information to be used by HEC-RAS. Our units, either English or metric. We specify our DTM, which is a TIN file, the stream channel, which is existing channel, our cross-section layer or MXS layer, map projection is state plane, the datum is WSG84, our DTM name is EG, number of reaches is 1. You may have more than 1. You could put 2 or 3. Depending on how many reaches you may have. The number of cross sections is 16, and our projection zone is Alabama East, and our vertical datum is WSG84. Hit OK. Here, now we are going to specify our cross section file and our alignment file. So we'll hit select by the sections, select channel A, select our alignment file, or MXS file, select channel A, and input our stream ID. I'll call this channel A. A. If you had multiple reaches, you could add another reach by selecting this button, but we only have one. So I will hit exit. And now this is the name of the actual HEC-RAS output file that will be used by HEC-RAS to bring in the geometry data. And now you can see the HEC-RAS file has been successfully written. Select OK. Now we are ready to import our data into HEC-RAS. So we will minimize Carlson and open up HEC-RAS, run File, begin a new project. We'll put this in our right directory first. And we'll call this channel A. Select OK. Begin the project. Now what we'll do is we can go right to enter geometric data and select File, Import Geometry Data in a GIS format. This will allow us to specify our geo file we just output from Carlson. We begin here. It's looking in the correct directory, channel A, geo. Double click that or select US customary units. Finished import data, and now you can see here the alignment and the cross-section data, and you can also view this with the cross-section within HEC-RAS itself and begin to go up and down and then start to supply the data that you need to find your watermarks and other information that you're looking for. Once you've completed your calcs in HEC-RAS, you can export information back into Carlson, and I'll show you how to do that by coming to File, Export GIS Data. We're going to create a file from HEC-RAS, an SDF file. We're going to do water surfaces, water surface extents, and rivers. We got all that stuff. We'll just export this data and see. Creates the file for us. We can come back to Carlson, zoom in here a little bit, go to watershed, back down to watershed modeling, let's draw the watermark. Here's our file we just created. Say OK, and you can see here that our watermark has been generated back into Carlson for your use there. We can also import flow velocity points from HEC-RAS. If you select Run, Steady Flow Analysis, and under Options, look at the flow distribution locations. We can set these, you can set them up to 45, but I'm going to set these here at 15 and just select OK. Do the compute, close this, select File, and Generate Report. Here you would want to select these settings and also flow distribution. Also you would want to set to standard table 1 and then Generate Report. Allow the program to complete, close, then open Carlson. Once inside Carlson, we can go to our points menu and set CRD coordinate file, the CRD file. Here we'll do New, Channel A is fine. Go back to the watershed menu, come down to HEC-RAS water surface modeling, and import flow velocity points. We'll select the file created by HEC-RAS, and here we will select our reach section file again. Select channel A, the reach alignment file, again MXS, the alignment file. We can import velocity CRD file. We can give this a name. We'll select channel A, and we'll call the description for the points flow velocity. And select OK. Now from here we can select Draw Locate Points. I've set my layer name to be Velocity Points, and I will select Draw All. And you can see that the flow velocity points have been added. To import flow depth points, we would follow the exact same procedure as we did with the velocity points. First thing we'd want to do is go to the points menu, and let's set a coordinate file. And here I'm going to select New. I'm going to call this one Channel A Flow Depths. Open. Replace it, yes. And then I'm going to come back to Watershed and come down to Import Flow Depth Points. We can select the file created in HEC-RAS, just like we did for the velocity points. And we can select the section file again. We can select the alignment file again. Set our CRD file for these points, and we'll call these flow depths. Select OK. Come back to points, draw locate points. I've changed this, just, you can see the coordinate file has been changed up here. I'm going to put these on a layer called flow depth points. You can certainly do it however you want, and draw all. And you can see that the flow depth points have been added. This concludes this tutorial on using Carlson software for preparing HEC-RAS importing and exporting files. For more information, you can refer to Chapter 6 of the Carlson User Manual, and thank you for watching this tutorial. Please visit our website at www.carlsonsw.com for future tutorials and product details.